Hello and welcome to Burris Agronomy U. This is Matt McEmery, sales agronomist with Burris. Today's topic, why do agronomists use small plot research? Well, the title, Stats and Dogs May Throw You, we really are going to try to give a quick but pretty good explanation for why seed companies like Burris use small plots rather than large plots. Now, as soon as you bring up the subject of small plots, you begin to hear very legitimate questions about how reliable those plots are. You see comments like this: why do you use small plots? In that small an area, the soil's all the same. That's not reality. My farm has varied soil types, and I don't farm a small area that's only a few dozen to several dozen feet long. You need to be doing long strip trials. In other words, you need to be testing in reality rather than using plot sizes that nobody works with in reality. As I said, those are very understandable, very legitimate, and very well thought out questions and comments, and to a certain extent the person asking such questions is right. We're not working in reality. In many ways, we're trying to not work in reality. So if we aren't working in reality, why not? It would be tempting to say, and to a certain extent true, that seed companies like Burris often are working with very small quantities of test seed that we need to stretch as far as possible. But there's actually a much better reason, and it should make growers feel pretty comfortable. We use small plots because we want to find out if there really are differences between hybrids. In other words, we want to figure out if one hybrid is better than another, so we can sell the better hybrid to help the grower's bottom line. And small plots help us get there. The discipline we call statistics helps explain this, but that subject can get pretty heady for an online tutorial, so let's instead work with a rough analogy. Let's imagine that you want to supplement your income. You don't feel like you make enough and you need to help the family out. You've always liked animals, dogs in particular. Perhaps you even wanted to be a vet at one time. And you develop your own type of dog food. Now bear with me. You think your dog food can help dogs gain weight better than any other product on the market. Remember, we're using an analogy here. We give it the name Bob's Magic Dog Food. You want to guarantee that it will increase a dog's weight. You're making a prediction as to how the dog food will perform. However, you need to know that your prediction is pretty solid. So you wisely decide to conduct a study to see if your guarantee for an increase in weight is true. We pick out a dog-loving family, one with a house full of dogs. So we give this family a call, mail them the product, and have the family feed a couple dogs Bob's Magic Dog Food, your dog food. And as you would expect in a study like this, we have the family feed a couple of other dogs regular dog food. We're having them compare our type of dog food to the other and trying to figure out which one is better at increasing weight. When all is said and done, lo and behold, the couple of animals that were fed Bob's chow gained 6 pounds, while the other dogs, those snarfing down the old brand, gained just 1 pound. Now the question I want to ask is this: did Bob's Magic Dog Food really work? Now some of you hear me ask that question and say, of course it worked. The family picked out 4 animals from the pack. 2 got Bob's Magic Dog Food and gained 6 pounds. The other 2 only gained 1. Of course it worked. But wait, you haven't ever seen the dogs in that home before. What if you see the animals and they look like this? What if the pack is all sorts of different dogs? You have dogs of all shapes and sizes. You have all sorts of different naturally occurring rates of gain. You have all sorts of natural variability in the family's collection of canines. Are you sure now, not knowing which dogs were fed the dog food, that your product worked? What if the 2 dogs that were fed Bob's brand were the St. Bernards and the other 2 were the Chihuahuas? You could feed St. Bernards and Chihuahuas the same dog food and have different rates of gain. We can't tell what's going on here. The product may have worked, and it may have not, but we'll never know because there's too much natural variability in this family's dog population. We can't tell if it's the food or just the type of dog that worked. The wide range in natural variability reduces our ability to see if the 2 types of dog food really are different. So how do we get around this problem? Well, I suppose there are two different ways we could do that, but it comes down to testing the product on the same thing as much as possible. When we do that, we decrease the natural variability that could hide results. So we could do this. We could look at a different family that has only St. Bernards, all about the same age, and we could test there. We could look at a different family that has only Black Labs, all about the same age, and we could test there. We could even look at another family with smaller dogs and test there as well. You notice in all these cases that we still have some variability. The dogs aren't all the same size. Some probably gain weight better than others. But by choosing the same thing, we decrease the natural variability, so we might be able to really detect if one dog food is better than the other. But what if choosing a family with just one breed really isn't an option? What if we still test our product out where a family has a bunch of different breeds? What can we do when we're looking at a bunch of animals with lots of natural variability? Well, one thing we can do is break that thing into smaller units. Again, this is kind of an exaggeration, but you can see what happens when we take the great big unit and we break it up into smaller units. By working with smaller units, we can decrease natural variability that might leave us unable to detect a difference between Bob's dog food and other off-the-shelf brands. Now imagine we aren't talking about dogs being given dog food. Imagine that we're talking about fields being presented with two hybrids. Just as was the case with dogs, each field has lots of natural variability in yield potential. Some soil types are just going to be better yielders than other types. By splitting a big field into smaller units, we decrease the amount of natural variability, just like we did in the last slide. A soil type, other factors, for instance, probably do not vary that much in a small plot. So we decrease the natural variability that might otherwise leave us unable to tell if differences were caused by the hybrid or caused by natural variation, soil types and those kind of things. By doing that, our ability to feel confident that we are detecting differences between hybrids actually increases. Now, the example provided has its holes, and there's probably more than one statistician who might howl at our dog analogy. No pun intended. Well, maybe we meant to do that. But it does provide a model that explains why seed companies and why researchers often rely and put lots of stock in small plots. Thanks a lot for watching.